Okay, next is dial plans and endpoint addressing. So defining dial plans, there are different factors that, like we discussed earlier as an overview. Now we'll see it in more detail. There is endpoint addressing for a dial plan definition. Dial rules for internal and external numbers are there. There is digit manipulation, class of service, call coverage, call routing, and path selection. So these are the different parameters for defining call plans, endpoint addressing, dial rules for external internal numbers, digit manipulation, class of service for providing like the privileges, call coverage to make sure all the calls are answered, call routing to route the calls on the correct destination via the correct path using the path selection. Dial plan documentation. So in dial plan documentation, you have to make sure a relevant to end user and administration documentation is there. So it should be relevant to end users and administrators. It should be up to date, clear responsibilities and processes, and accurate documentation is provided. In dial plan, there is endpoint addressing, which means assigning DNs to the endpoints. Call routing and path selection, which is another path to the same destination in case you have multiple paths for the same destination, how you will do the path selection and how the call will be routed. So that can be done in call routing and path selection. Digit manipulation for pre-routing, post-routing. So let's say if you have to add any prefix to any number when dialed, or remove or strip the some digits when the call response is coming back. So post routing, pre-routing, digit manipulation can be done. Calling privilege is to grant or deny access to certain destinations. Call coverage are avoid dropping calls for certain incoming calls, especially like the customer care. So here we can see an example of endpoint addressing. So dial plan components and functions endpoint addressing. We can see here, let's say we have an headquarter. Headquarter has numbers starting from 2001, 2, and 3. So a logical number plan is essential for scalable dial plan implementation. In this case, every location has a unique 4-number digit range. Similarly, here on the site also we can see it starts from 3001, 3002. So that is endpoint addressing. Similarly, on this site also, we can see 4001, 4002. Dial plan components and functions, call routing, and path selection. So here we can see going from the headquarter to the site 1, we have two paths available. One is the PSTN line, other is the IP WAN connection. So to go via any one of these, we have to implement call routing and path selection so that it can take the path as per the primary. If the primary fails, then it should route to the secondary and so on. So here in this case, it is going via IP WAN, which is configured as the primary. If the primary link fails, then it is going via the PSTN. Okay, so first choice, second choice, third choice. This is what we have to configure: primary, secondary, tertiary, path selection, or call routing. So first, let's say is the IP WAN. Second choice is the cheaper PSTN, and third choice is the expensive PSTN. So based on the requirement, it can be cost, budget, or bandwidth, or speed, anything. We can set the choices here for path selection. So as here we can see, we have IP WAN as the first choice. Then we have a cheaper PSTN for the second choice if the IP WAN fails. If the IP WAN and the cheap PSTN fails also, then the third choice is an expensive PSTN. Dial plan component and functions digit manipulation. So like we know that in headquarter, we have numbers configured as 2001, 2002, 2003. Now, when we have to make a call to a PSTN, for example, we have to make a call, for example, 2003. This user wants to dial 4001, which is in site 2, 4001. The dialed number is transformed to this and sent to the PSTN. The PSTN will not allow this 4-digit number because that is not a standard number which is allowed by a PSTN. So we have to make sure we have to convert it to a standard PSTN number. So for that, we will add a prefix 408555 before the destination number 4001. Right? So that is where digit manipulation is required. Then other example is a call is sent from the PSTN to is transformed to the extension 3001. So when a PSTN phone is dialing to this phone on the number provided to it 51255530001, when it comes to the gateway or the CUCM, let's suppose this is the CME here, it needs to strip the numbers back to make it a 4-digit number, which is in the internal network that it knows. So it will again do a digit manipulation, change this number back to 3001. So pre-routing, post-routing, both digit manipulation can be done. Then calling privilege, providing or granting access or denying access. So calls can be permitted or denied based on calling device and called number. So let's say phone 2001 has sufficient privileges to place a call to site 2 via PSTN. Phone 2002 does not. So phone 1 has the privilege to call site 2 via PSTN, whereas phone 2002 does not have that privilege. That can be set in calling privileges. Then call coverage, that all answer calls should be answered. So for example, a phone 4001 call hunt pilot 2222. Depending on the hunting algorithm, one of the hunt pilot member receives the call. So let's say from this user, this has a pilot number 2222. This is like, let's say I want to order a pizza, and this is the customer care number that we have. All the users are using the same numbers, but it is not just a one phone. It is associated with a lot of phones with multiple phones, so that all the calls from the users on the same number is answered. And then behind that, when it is associated with the multiple users, there is a algorithm which is running, that how it will be uh, covered, how all the calls will be answered. So there is an algorithm like top to down manner the call will go, or will it be in circular or longest idle, which is the default. We will also discuss about that. So here, when 4001 dials this pilot number, which is a open number, public number for calling, let's say, the headquarter. This is the pizza delivery. So one of the Hunt Pirate member receives the call. So one of these members will receive this call based on the algorithm configured. Second example is when the phone 3001 does not answer the incoming call, which is forwarded to configured ring on answer destination. What we can do is call coverage also. Let's say the call is coming for any particular destination, but is not available to answer, or is busy, or has forwarded the calls. It can be done to any destination within the network. So there are different call coverage options that we can do. Endpoint addressing. So here we can see two types of endpoint addressing. Either directory number can be assigned to endpoints, or directory URIs. Yeah, URIs can be assigned as well to the directory number. So let's say for this user, you have a directory number 1001 and a URI joe@cllcollab.internal. Similarly, for the second user, the DN number is 1002 and the URI configured is jwhite@cllcollab.internal. Endpoint addressing by numbers. So numbers can be 4-digit numbers or any number of digits that we want to configure for our internal networks. We can add a PSTN DID number. PSTN DID number can be in two formats, E.164 or any NP format. So let's say this is the directory number we have configured, and to make calls outside, we want to add a DID PSTN number, this or this. Okay. Plus is used, or +1 is used for US as per E.164 standard, whereas in any NP you do not need to add that. You can simply add this code and that's it. Call routing steps. So local endpoints and immediate call control can be done via CUCM for any destination, which depends on the route lookup or finding the best path. It finds the best match entry in the routing table. So like the routers, every time when the packets are received, it do a route looker, finds the best path for that destination and then forward the packet. Same way CUCM use the same concept. It also has a routing table where it will look for the best match in the table and then take the decision and then forward the request. Sources of call routing requests are different. So different entities requiring call routing table lookups are done. IP phones, trunk, gateway, translation patterns, voicemail ports. These all can be configured for call routing requests on CUC. Now, digit by digit analysis of numbers not received in a single block. So let's suppose you have some patterns configured, and when these patterns are configured, these are in the routing table. When any number is dialed, a digit by digit analysis is done. So let's say you have potential matches, these. So these are all the patterns you have configured. These are the patterns configured. One XXXX means any digit, 0 to 9, any digit. 11 XX, 1001 specifically, and 2000 specifically. So we are allowing only calls matching these patterns. So when a user dials number 1001, so this is how it works. So starting off with when nothing is being dial. So no digit is sent. That means potential matches are all these patterns which are configured. Nothing other than these matches will anyways be allowed, only from these. So all these are the potential matches at this point. When the first digit is dialed, the first digit is 1, let's say. So I have dialed 1. So now it will filter, and based on the potential matches, only these are matched. 2000 just goes away because the first digit is 2 here, so this is not a potential match anymore. When the second digit is dialed, I've dialed 0. Now my potential matches are these two and not this, because here the second digit is 1. So 1 XXX and 1001. These are the two potential matches. Next I dial a 0. Now again, both of these are a potential match. Lastly, I dial a 1. Now it will go back to here, but out of these, because the specific match or the best match is 1001, apart from 0 to 9 here, it will go ahead and match this number and dial this caller 1001. So this is how the digit by digit analysis is done. Then in digit analysis and digit manipulation, we can also use exclamation point for wildcard. Now, exclamation point means any digit. So one or more digits can be there behind an exclamation mark. It is a variable length route pattern. So let's suppose for international numbers, you do not want to put any specific number, as there are multiple international numbers you can allow. So if let's say you just want to say that any number starting with +190 should be allowed, and then it can be any number. Let's say the whole number is a 12 digit or up to 15 digit. Any, you want to allow any starting off with these. So then you can just put an exclamation mark. So it can be any number of digits and any digits. Okay. And there is an interdigit timeout also for this. The interdigit timeout by default is 15 seconds. So if let's say I have dialed +190,123, and then I have not dialed anything, because there can be any number of digits behind it. How long will it wait for me to dial another digit, or to know if I have dialed all the digits? That is 15 seconds. 15 seconds default time. Service parameter, call managers cluster wide parameters is where your default timer or interdigit timer is configured. Users can use a hash to indicate the end of dialing. You can also do a hash after this to indicate a end of dialing. So implementation requires an identical route pattern with hash sign. CUCM implementation is unlike iOS dial peer implementation. So in iOS, we configure it with hash. In CUCM, we use exclamation. Overlaps and interdigit timeout. So here, let's say we have dials 13115. So it will match this pattern 13 exclamation mark. After the expiration of interdigit timeout, it will dial this number. If you dial 131, it matches 131 after the expiration of interdigit timer. Why? Because these are the patterns we have configured. You can see 1111. This will obviously not match it, so it will go ahead and see the potential matches here. And it, as we have a 13 exclamation mark, so it will go up to this one and will wait for the interdigit timeout to expire, and then it will make a call to 13115 and not straight away. If you dial 131, then the potential matches are this. We have 131, we have 13 exclamation mark also. So it matches 131. If you just stop here dialing 131, as we have a exclamation mark here, it will wait for the interdigit timer to expire to make a call specifically to 131. Then if we dial 1415, another example, so it will match this pattern and no other, because the second digit is 4, so it does not match this one, or this one. Okay, so it matches with this without post dialing delay. All right, then about voice gateways. So when we configure voice gateways, dial pair needs to be configured on the gateway. So dial pairs connects the incoming call leg to outgoing call leg. So when you have to make call from inside to outside, you need to configure these call legs, incoming and outgoing, which are called dial pairs. Configuration is applicable to each call leg is taken from selected inbound and outbound dial pairs. So based on that, we will be able to make calls and route calls. So as in routing also, when we do routing on routers, you need the destination, you need the information of the source to the destination, the path, so that the call will be routed. Same way, dial pairs are required for that purpose to define a path. A dial pair can be used as an inbound or outbound dial pair. You can configure inbound or outbound dial pairs. Separate dial pairs are configured for POTS versus VoIP call legs. Now, POTS is used when you have a T1 even connection. The two types of dial pairs are there. These are the types of dial pairs, POTS and VoIP. So POTS is used for T1 even connection. So if you have a T1 even connection, then the dial pairs we configured are POTS dial pairs. And if you have a VoIP connection, like WAN connection, IP WAN connection, then VoIP dial pairs are used. So the main components of voice and POTS dial pairs are these. These are just some configuration types or the difference in configuration of voice on VoIP and POTS dial pair. So VoIP dial pair can be in this format, like destination pattern, this session target IP, this will be your CUCM, translation profile, incoming PSTN, voice class, codec, preference, incoming calling number, called number, answer address, and so on. Same way for ports, this is like destination pattern is this. Session target is same here, but port number is defined here as the port for signaling 1/0/0. It can be different for different routers. Translation profile, incoming or outgoing, preference, digit strip if you want to do a digit stripping, forward digits, incoming call number, answer address, and so on. So some commands are similar, but there are some differences in the configuration. Now, time division multiplexing gateway inbound dial pair selection. So when we are doing an inbound dial pair selection, the priority is in this order. First, incoming call number, answer address, destination pattern, port, and no match, the default dial pair is used. These are some attributes which are used in inbound dial pair. Similarly, for outbound dial pair, there is a destination pattern that matches the called number, best qualified match, Lower preference, random dial pair, no match will affect the call and we call the will fail. These are some parameters in outbound dial pair. Destination server group. So destination server group supports multiple destinations per outbound dial pair. It uses a round robin or preference order. Up to 5 servers per group can be configured. It reduces the need to configure multiple dial pairs and you can use the option keep alive profile for this. So what we can do is instead of configuring multiple outbound dial pairs, we can also do a destination server group. In that server, you can add what all users are there based on their IPs.